So this is going to be a pretty short and simple lesson on exponent rules. There aren't very many of them. They're kind of easy to pick up on, so let's just get right into them. The first rule is when you're multiplying two of the same base but the exponents are different. We're going to kind of rehash what it means to be x squared. That means x times x, and that means that x cubed is x times x times x. So if we multiply these two together, we have 1, 2, 3, 4, 5. That means that this must be added together because 2 and 3 make 5 when you add. So the first rule is when you're multiplying, you add all these, except nobody likes to write it like this. That's why we use the shorthand, which is exponents. So when you're multiplying, you add these two numbers and that becomes your new exponent. So that one's pretty easy. The second rule is when you're dividing, let's say I have x to the 8th over x to the 5th. Okay, well this would be really cumbersome writing it the non-short way. So here I have 8 up here and I have 5 down here. And we can see that this would be the long way to do it. When you see it like this though, you can see that anything over itself is 1, 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 and anything over itself is 1. That means I have 1 times 1 times 1 times 1 times 1 times x cubed. So that answer would be x cubed. Well, let's see how we'd get x cubed out of this. We have an 8 and a 5, and my answer was a 3 for an exponent. That means I must probably need to subtract these two. So 8 minus 5 is 3. So this rule is when you're dividing, you subtract the exponents. Or you can have this sort of war where 8 guys on the top, 5 guys on the bottom, one man gets one man all the way down until you have what's left. So that's another way to think of that. Okay, let's clean this up. So the third rule is stemming from the second rule. So we could call this maybe rule 2b, but we'll just call it rule number 3. And that's that anything to the 0 power is 1. And if we could see this rule in action, maybe like x to the 8th over x to the 8th, we could see that 8 minus 8 would give me a 0 when I subtract the exponents like I did here. Well, anything divided by itself is 1. So that must mean to get a 0 power that these exponents are the same, and when that happens you get a 1 here. So that must mean that this is always true. So that's why anything to the 0 power is 1. So that rule is pretty easy. Okay, the next rule also comes from this rule, and it happens when you have the bottom, which is the denominator, bigger than the top. And so we'll subtract the exponents here and get into negative numbers. And so you'd say, well, what does that mean if you have a negative number? So that's the fourth rule. Is when you see a negative exponent, that means the bottom was bigger than the top. So if we'll see this one in action, it would be 5 here and 8 down here. And we can see that this man would get this man and so on all the way down. And this man would get that man that I missed. And we would have 3 left down here. And a placeholder up here, which is an invisible 1. There's like, at any time there's nothing left, there's not a 0, it's a 1. So this answer is 1 over these 3 guys down here, x cubed. X times x times x. So the fourth rule is when you have a negative exponent, that means the bottom must have 1. Because when you subtract and you get a negative number, the 8's bigger than the 5. That's how you get the negative number. So that means that the bottom has more than the top, or the bottom has the winner of the war. So negative exponent, this scenario right here means this right here. Okay, so negative exponent, put the variable on the bottom and make the exponent positive down here. This is kind of a strange one. This is the hardest one for kids to pick up, is that negative exponents turn into a fraction. So don't forget that one. Okay, so let's do some examples. So this example has a lot in it. We got two things multiplied together, and each of these two things have their own exponent on it. So our order of operations, which you might remember from Algebra 1, says do parentheses first, which means I'm going to do everything in here. There's nothing to do. Do everything in here. There's nothing to do. So that's done. Move on to exponents. Okay, so I'm going to do this exponent and do this exponent. Alright, well, remember that something squared means times itself. So this is actually the last rule that I'm going to review, and that means that when you're doing one power to another power, like x squared squared, that actually means just something times itself. So that's rule number 1. So we'll add these exponents together. Get x to the 4th. So this would be x squared squared, or x to the 4th. Y cubed squared would be y cubed times y cubed, which is rule number 1. Add these two together. So this is the last rule, which stems from rule number 1, and that's power to a power. This is what you do when you have one power raised to another power. You either think of it like this, or you could multiply the exponents as a shortcut. 2 times 2 is 4. 3 times 2 is 6. See over here, x to the 1st to the 4th power. So x to the 4th means x times x times x times x. Y cubed to the 4th. Well, that means y cubed, y cubed, y cubed, y cubed. So this would be y to the 12th. That's why I said the shortcut is to just multiply these guys. You don't have to write it all out. Okay, so we got x to the 1st to the 4th, just gives me x to the 4th. Y cubed to the 4th means y cubed times y cubed times y cubed times y cubed, 4 times. That's what 4th power means, times itself 4 times. So add these exponents up and get a 12, or do the shortcut. 3 times 4 gives me a 12. Okay, let's see if we can keep going. We did exponents, let's see if we can multiply these two things together. And we can. We're going to multiply our x's together. X to the 4th times x to the 4th is x to the 8th. Y to the 6th times y to the 12th is y to the 18th. And this is it right here. Okay, here's your last example. We have all this stuff to this power. So order of operations says do everything inside of the parentheses first. Well, one thing we could do is clean up in here and then raise all that to this power. So we could do that, and that would be anything in here is similar. Well, these b's are similar, so we could clean this up. There's no a's on the bottom to cancel with this one. There's no x's on the top to clean up with this, but we can combine these b's. So we still have something to the -2 power. We still have an a squared on top. When these b's have a war, the bottom is going to win, and there's going to be 2 left. This 1 will take away one of these. So there are 2 left down there, and we have an x squared. Okay, now we'll apply our power rule. We did our parentheses, now move on to exponents. Remember, I just said power, one power raised to another power, a squared to the -2 power. Multiply the exponents, so that's -4. So all of this in here is getting raised to this power. So I'll move on to this one. B to the 2 to the -2 is b to the -4. X squared to the -2 again is x to the -4. So this is what I get after I raise everything to the -2 power, and we don't want to leave negative exponents. So all of these are going to change. Negative exponents means move to the other side of the fraction and make them positive. So this must be down on the bottom, a to the 4th, and these must be on the top, b to the 4th, x to the 4th. That's a strange rule, but that's the rule for negative exponents. Move it to the other side of the fraction and make positive. Just like in the instruction when it said this, basically this is over 1. You move it to the other side of the fraction, this is what we did, and make this exponent a positive. So this is the example we did that was simple. Here's the example we're doing that's more complex.